this example, what I did here, I just design it. At the same time, I'm making the rendering. Okay, if I want to make, for example, a rectangle. Okay, so I can make G2 dot. So here, how to create a rectangle or how to draw a rectangle, we can use draw, and then we can select a rectangle. And then I have to give here the options. So here, for the rectangle, what is the first? What do you have to put for the first coordinate here? What do you have to put here? This is our rectangle. How to draw this rectangle? Yalla, try to participate. The starting point. So how to give this point, P1. Okay, so we have to give here the X and the Y of this point. This is X and this is Y. And then we have to give the width and we have to give the height. Okay. Now let's suppose that we want to start with 100, 100. We need the width of 300 and we need a height of 100. So how to do this? So here for this value, it should be 100. The second value, yeah, 100, very good. And the width?
300.
300, the height?
100.
Okay. So this will draw, so no need for the first instruction. This will draw the rectangle. Let's close this. So you can see that here we made the modeling and the rendering at the same time. We cannot separate modeling and rendering. Okay? I can change the color. I can, instead of drawing the rectangle, I can fill the rectangle. Okay? So here G2.fill rect and the rest will be the same. And you can see that here we fill the rectangle. You can change the color. Let's use the color red, it's okay. Now you can see that we are filling this rectangle. Any question about this? So here at the same time, we are making the design and the modeling. We can use modeling for design, okay? And also we are making the rendering. So this is P1 and this is, sorry, this is the width and this is the height. Okay? So I've seen that we can create, with this technique, we can create a rectangle. We have seen that you can also use round rectangle. Yes or no? So fill instead of rect, we can use round rectangle. And then you have to add here the two diameter, D1 and D2. I've seen that for round rectangle is something like this. Okay, sorry. So here we have to give this diameter D1 and this is D2. So we can add here the two parameters. Let's make it, for example, 20 as T1 and 20 for D2. You can see that here we are filling this rectangle. You can change, you can make it here 80 for D1 and 80, or let's make it 50 for D2. Is it clear? What have we seen else? We've seen the rectangle, we've seen the line, we've seen round rectangle. What else? We've seen the oval. Yes or no? So let's see the oval. Oval or ellipse. So here we can use G2.draw oval. So here when you make G2.draw, you have here all the options. Okay, you can draw a polygon, you can draw an oval, you can draw a line, you can draw an image. Okay, so here we want to draw an oval. So for the oval, same thing. So this is the oval. Okay, so here we have to give the coordinate of this rectangle. So for drawing the oval, we need to give this point, P1, for example, and so with the component X and Y, and you have to give also the width and the length or the height of the rectangle. Okay? Yeah, let's make P1 at the same point 100 from 100. And let's make the width of our oval 200, and let's make the height 150. So here we are drawing the oval. You can see that we have the oval. We can change the color. We can make it, for example, green. And we can fill the oval. So here, same thing. We are combining both the modeling and the rendering. So fill oval, this will fill the oval that we have created. So now we are filling this oval with the green color. Any question? We can also use an arc. So we can use an arc. So what is an arc? Is a part of the ellipse. So we can use, for example, here some part of an ellipse. So here we need the two angles here, θ1 and θ2. So let's run this. Now I want to fill an arc. We can G2 dot fill or draw. Let's make it draw. And now we can, I want to select an arc. Okay, so we can select arc. And then we have, first of all, to give the point, which is the same point of the rectangle. Let's use same point 100, 100. Let's use the width of 200 and the height. Let's make it circle. Height also 200. And then we have to give here two angles. Let's make starting from angle 0, and let's use here the angle 90. I have to remove this. So you can see that here we have an arc. So let's fill the arc. Are you with me? Please stop me. If you have any question, please stop me, okay?
Doctor, I have a question.
Okay. Go ahead, please.
The first two arguments indicate where it starts.
Okay, I'll explain again. So here I want to make an arc from a circle, okay? Now to do this, to draw the complete circle or to complete oval, you have to use draw oval. Okay, now let's return back to the oval, okay? So for the oval here, we have to give these values. So this point, P1, with the X and Y component, and we have to give this width and this height. Is it okay for the oval?
Yes, it's okay.
Okay, for the arc, we have to give also two angles. Okay, so the first angle here, so here we start, this is the axis, okay? So here we can see that we started from the angle 0, and here we ended at the angle 90 degree. So this is the 0 degree, and this is here we have 90 degree. So these are the two additional arguments. The starting theta, and here the what is the opening here, how many degree, okay? So if we start here, if we can start from 90, for example, and we can make it 45 degree. So if we start from 90, so here we are starting from this position. Okay, and then if we make it 45 degrees, so 45 degrees starting from this position, it will be something like this. Okay, so let's try this. So here we can change it. We start from 90 degree and let's make it 90 degree, okay? Close this. Now you can see that we have the second quarter. If we make it 45 degree here, so we start from 90 degree and we have an angle theta of 45. Okay, so the first value that we gave, this theta here, let's call it theta 1. And here you have theta 2. So theta 1 is this one. This is theta 1. And the second value here, theta 2, is from here. This is theta 2. Is it clear? Any question about this?
No, thank
ما
you.
نقدر نسوي من هالكود دائرة كاملة.
Yes, you can start from 0. Yani you want to make a circle starting from an arc. Is this your question? Yes, you can start with any theta. Theta 1 here can be any value, and theta 2 should be 360. You will find the complete circle.
Okay, شكرا.
So let's try it here. We can start from any value. Let's start from 0 and let's make it 360 degree. And now we can see that we have the complete circle. Okay. So if you want an oval, let's make it here 300. 150. Now we have an oval. Okay, if we need an arc, let's suppose that we need half of this oval. We can start from 0 and we can use here a theta of 180 degree. You can see that we will have half of oval. Okay, question. If we need the second half here, how to do it? We need this half here. How to do it?
Start from 180 to 0.
So we start from 180 and theta 2. So this is theta 1. From here till here. And what is theta 2? Starting from here till here. So here, let's say 180. You can try this. 180, 180. And have the second part of the oval. Is this clear? So here in all this part, we are using the graphics, top graphics 2D, and we are combining the modeling and the rendering. In today's class, we will see how to separate the modeling and the rendering. But I think we missed the parametric equation. So in lecture 2, some students asked me about the parametric equation. Like this example. So what does mean a parametric equation? So if you have just standard graph, so generally what do you have, how to make plot? So generally you have here y equals f of x. So how to draw this? You can create just a vector x is a vector, for example, from 0 till any value, okay? 1100, and then you can calculate the y, which is f of x. So it is very simple. So in math, it's very easy to do it, okay? You can have a table. You have a value of x, you calculate the value of y. Okay, you have this value, you can calculate y. You have this value, you calculate y, etc. Now, for the parametric equation, we have here, for example, x equals f of, we have a third variable, let's call it t. And we have also y equals f of t. Okay, so this is called parametric equation. So in math, how to, if you want to make a plot, so generally here we have to make a table. And then here we have t. And for every value of t, you have to calculate x and y. For t equals 0, we can calculate x, we can calculate the y. For t equals 0.1, we can calculate x, y, etc. And then we can plot the values. So now in Java, how to plot something like this, how to make a graph like this. Now let's suppose that you have the different values. Let's have here 0.2. We have value here. Let's make it here x0, y0, x1, y1, x2, y2, 0.3, we have x3, y3, etc. So here the idea is to, so let's suppose that we have here the equation of circle. So what is the equation of circle? So here y equals a multiplied by cosine t, and this is for the x, and y equals a multiplied by sine of t. So this will give you a circle or an oval. If you use the same a, it will be a circle. If you have here a and then you have b, so it will be an oval. Okay. Now how to do this? So we can calculate x0. So x0, y0, this is the first point, p0. x1, y1, this is the second point. Let's call it p1. Now we can start by plotting a line between p0 and p1. Let's suppose that this is p0 and this is p1. Now we can start by making this plot, this line. And then we have to make a plot between, or a line between p1 and p2. Let's call it, this is p2. I have to make a line here. Then this is p3. I have to make a line between p2 and p3, etc. So to do this, you can make it as a loop. So we have always 2 points. Okay, now let's use the eraser. Okay, so here I'm using this. Okay, so we have to make a loop, and in this loop, we have to calculate here the xi's. Okay, so we have a variable I from 0 till any value, and then we have to calculate x of I. So x0, y0, and then x1, y1, then x2, y2, etc. So here, this will give us the first point. So for example, p0, and this is the second point. Let's call it p1, or we can use p1 and p2. Now we have to draw a line between p0 and p1. This will make the first line. Then in the loop, I have to calculate the next point here. Now, after calculating the next point, we can now remove this P0, and let's make the P0, which is the last point. And the new point here will be P1. Okay, and now same thing, we are making a line between P0 and P1. So now this is P0, and this is P1. We are making the line between P0 and P1. And then we have to calculate the next point. And then this will be our P0, and this will be our P1. Okay, and then we are making a line between P0, this is P0, and this is P1. Why we are doing this? Because we need to create an instruction, and we are repeating this instruction. So what is the instruction that we are repeating? We are creating a line between P0 and P1. So this is the idea of the parametric equation. So here we have an example, or we can directly open the example that we have on LMS. So you have the parametric skeleton, which is the skeleton that you have here. Okay, parametric skeleton. If we download it here in lecture 2, you open it. Fine. And then open project. Parametric skeleton. So this is the skeleton. We will make it like this. So if you download the skeleton, you will find this code. Okay. So what do you have in this code? So this is the paint component. You can see that the code here is in the paint component. So our code starts from here till here. Okay. So what do you have here? So here we have view transformation. So here we are just changing, so translate, G2.translate, we are making translation of the view. That means if our screen is like this, okay, so this is the origin. This is the point 0, 0. Now, if we translate 300 over the x-axis and 300 over the y-axis, It means like our new origin will be here. So it's like we start viewing. So it is a viewing transformation. So it's like here we starting. So our new origin will be from here and not from here. So this is the point 300, 300. And then we are declaring here, we are making the declaration of the variable. So here, what do you have in the variable? So at the end, you have to calculate 2 points, P0 and P1. And then you have to make a line between P0 and P1. Then you have to calculate a new point. This new point will be the new P1, and the previous P1 will be P0. And then you have to make a line between P0 and P1. Okay, so here, we are calculating the point P0. So here, let's suppose that, okay, so let's make it 100, 100. So here I will give you everything. So here we are supposing that you want to create a circle or an oval. Okay, so the expression of the oval here is that we have x equals a multiplied by cosine t, and then we have y equals a. So if you use the same a, let's make it b multiplied by sine of t. So if you want to start with x0 and y0, you can make here plus x0. And here we can make plus y0. But if you want to start from the origin 0, 0, we can remove this. Okay. Now let's make our a equals 100. Let's make our b equals 100. So it will be circle. Okay. And then let's make the t between 0 and, so here will be between 0 and 2 pi to make here one circle. So we need to draw all the lines here. And the values of t, we need the values of t between 0 and 2 pi. Okay. And let's suppose here we need a number of points of 100 points or 1000 points. Okay. So here we have a number of points which is 1000. Number of points, that means we are repeating the process here 1000 points. And then x0, y0 are the coordinates of p0, x1, y1 are the coordinates of the point p1. And now we have to calculate p0. What is the first point, P0? Well, just to replace T with 0, the first value of T is 0. We have to return back here to this equation. We have to make just T equals to 0. So your X0 will be 100, which is our A, multiplied by cosine of 0, because here our T is 0. And then Y0 equals 100, which is the B, multiplied by sine of 0. This will give us the point P0. And then we have to calculate P1. So how to calculate P1? Now I will increase the value of t. Okay, so now we are using here a variable I, and I is from 1. We don't start from 0 because we took already the value 0. We start from 1 till 1000. Okay, so or I less than 1000. So we are taking 999 points. Okay, because we have already the first point P0. So here, what are we doing? Now, I need that t is between 0 and 2 pi. And we have an I between 0. Let's use the I here between 1 and 1000. So I'm supposing that here less than or equal. Okay. Now, how we can find, so here we want to make a cosine of t. Okay, so how to calculate this t? By using this I. So the loop in the loop we have I, we don't have t. But in the cosine, we have to make cosine of t. So how can we calculate this t? So when I equals to 1000, so this 1000 is n. When I equals 1000, t equals 2 pi. So I will do it like this. So when I equals to n, the t equals to 2 pi, because we need t between 0 and 2 pi. So we can multiply this by this and this by this. So we can make t multiplied by n equals I multiplied by 2 pi. So how to calculate this t? So the t will be I n. This is how to find the t. Now we need an I between 0 t 1000. This will give us a t between 0 and 2 pi. So this is how to calculate the t. So here you can see that you are calculating the t. So the t equals 2 pi. This is the 2 pi multiplied by I divided by n. And here we are making casting of n to make it as that, because we are dividing by n. So this is how to calculate the t. Now, once we have the t, now we have the first value of t. So if we trace the algorithm step by step, so here the first value of I will be 1. So in the first iteration, I equals 1. What is the first value of t? T will be 1 multiplied by 2 pi divided by n, which is 1000. So which is 2 pi divided by 1000. This is the first value of t. And then we have to calculate now the second point, which is P1. So how to calculate P1? We have to use the same formula with the new value of t. So here we have A multiplied by cosine of t for the x, and for the y we have B multiplied by sine of t. Now what do we have? We have P0 and we have P1. We can now draw a line between P0 and P1. So G2 dot draw line, this is P0 and this is P1. We are drawing a line between P0 and P1. So this will give us, for let's suppose that this is P0 and this is P1. This will make this line. Now, after drawing the first line, we have to update P0 and P1. So what is the new value of, what is the new P0? The new P0 is the previous P1. So this P1 here will be P0. And then we have to calculate P1 again. So this is what I'm doing here. X0, Y0 equals X1, Y1. That means here we are making, so it's like having P0 equals to P1. Okay, we are changing P0. So the previous P1, now it is P0. And then we have to calculate P1. So we have to calculate P1. That means we have to turn back here to the loop. Now we have to increment I will be equals to 2. Then we have to calculate T. And then we have to apply this T to calculate P1, X1 and Y1. Then we have to draw the line between P0 and P1. And then we have to update P1 again. And we have to repeat this how many times? 1000. Is this clear? It's very simple, and all the program in which you have parametric equation, it is programmed similar to this one. You have just to change here x1 and y1. That's it. And also x0, y0. And you have just to change the formula of the point. Okay, so you have to select the number of points in the plot. You have to calculate P0. You have to calculate here, you have to make the loop, and then you have to calculate T. Once you have T, you can calculate the coordinate of the point. And then you have to draw a line between P0 and P1, and then you have to update your P0 and return. Now we can run this. You can see that here we have circle. Why it is a circle? Because here we selected A equals to B. Let's change now, let's make here 200 instead of 100. Now we are changing the B. Now it will be an oval. You see that now we have an oval and not a circle. So this is the parametric equation. Now, on the slides, you have other equations. For example, here, spirogram. Let's suppose that you want to create this plot. So what do you have to change? You have to change just the values of x1 and x2. You have to use now this formula to calculate what? To calculate x0, y0 before the loop. And then you have to use the same formula to calculate x1 and y1. The rest will be the same. So here we have another example. For example, the stages curve. So what do you have here? For the stages curve. So you can see that you have formula that is similar to the previous one. So for the circle, what do we have? We have x equals a cosine t. And for the y, we have y equals b cosine t. Now here, what do we have? We have almost the same thing, but here instead of t, we have kx multiplied by t. And here we have ky multiplied by t. So we can define kx and ky. We can give the values for kx and ky. And same thing here, our t here should be between 0 and 2 pi. So the formula of t, I've seen how to calculate it. So the t here will be I multiplied by 2 pi divided by n. So let's update program that we have here to create the messages here. So I have to create kx and ky. So here we can make int kx. Let's make it equals to 4, for example. Let's create ky. So int ky equals to 5. Let's make it 6. And then I have to change the formula here. Okay, so here we can use a and b, for example. Let's make a equals 100 or int a equals 100. And let's create a b, so for the int b equals, we need an oval, so let's make it 50. Now we have a and b. So here we have to make a, and here we have to make b. The same thing here in the body of the loop. Here we have a, and here we have b. So now we are trying to make it as close as possible to the mathematical equation. Okay. Now instead of t, what do we have? We have t multiplied by kx. So here you can make it kx multiplied by t, and then here we have ky multiplied by t. So now what we did, we created the program of the messages, which is this one. So we updated just the values of x and y in both in the calculation of P0. So we have to update the values here for the calculation of P0 and for the calculation of U. Okay, now we can run this. It's not working. Okay, so we didn't change the value here. So we have to kx multiplied by, and then ky multiplied by t. So I updated here P0 and P1. Now you can see that we have used the messages. Good. So let's change the B. Let's make it 100. The same plot. So here, if I want to see all the plot, I want to see curve like this. Okay, let's change ky. Let's make it 5. You can see that when you change the values of kx and ky, you are changing the plots. Okay, we can try 3 and 4, 3 and 5. So you can see that now we have this plot, which is similar to the plot that you have. Okay. Change again, we can make 5, we will make 3. You can see that now we have this curve. Any question about this? Here we just changed the values of kx and ky. We can make here 3 and here 4 or 5. You are changing the 4. Okay. You can change b, you can make it 200, you'll find another 4.
السلام عليكم دكتور.
وعليكم السلام ورحمة الله وبركاته.
دكتور أنا راح أطلع بسبب عندي دوام.
خلاص ما في مشكلة، حاول تكمل معنا. اوكي
تمام يعطيك العافية.
So if you have to make the graph using parametric equation, you have to update here the calculation of P1. You have to update the calculation of P0. And then for the t, let's suppose that you want a t from 0 till 10 pi. not 2 pi. You have just to make here 10 instead of 2. Okay. Any question about the parametric equation? So you can download the program of the parametric equation from the LMS. So here we have parametric script. Okay. So here you have some other examples. So what do you have in this example? You have just here the values of x and y, and here we have the values of t. So in this example here, this is our x, this is our y, and this is our t. Here you have the x, you have y, and you have the t. Here you have the t between -3 and 3, and then you have x and y. Okay, so you can try these at home. Any question? So we took almost 45 minutes to make a revision. Any question about this? Okay, so in lecture 3, principally we'll focus on how to separate the modeling from the rendering. So now in this lecture, we'll use graphic 2D, not the graphics. We are using here the graphics 2D. So in graphics 2D, we can make a separation between the modeling and the rendering. That means you can create shape. Okay, so whatever the shape is, you can create the shape. For example, this is our shape. So I can create the shape. After creating the shape, I can make the rendering. I can draw the shape. I can fill the shape. I can fill the shape with an image. I can add a texture, etc. Okay, but first of all, you will see how to create a shape. Now, when you create a shape, you will not see this shape. Okay, then after creating the shape, you can make the rendering. So the rendering can be drawing, or can be filling, or there are many types of drawing. Okay. Yeah, let's continue. So the objective are to understand more graphic primitives. We see more graphic primitives. We will see how to construct more complex shape from the basic primitives. So we see, for example, how to create one area. And let's suppose that here we want to make a rectangle like this, and we need to subtract, for example, a circle from this rectangle. Okay, so we'll see how to do such operation. Or we made, for example, the first circle, and we want to add here another circle, so that at the end I have this shape. So here, what are we doing? We are combining, or we are adding the two areas together. We can make one area minus another area. I can have something like the moon, for example. Okay, so how can we make this? We can create a circle, and from the circle we can subtract another circle. We can find something like this. Okay, so we see how to add areas together, how to subtract one area from another area. So here we are combining the basic primitive to make a complex shapes. Okay, you'll see also how to construct custom shapes by using the general path. So here in the general path, generally you are creating. So we can start, for example, one point. From one point, we can go to another point, and then we can go to another point. Then we can move without drawing. Then we can make a line to another point. So this is how this new, what this new general path, and we'll see how to make the general path. And you see also how to construct geometric shape through the constructed area geometry. That means we're addition, subtraction, etc. Okay, so graphics 2D contain two methods. So here we can use the draw method. For example, we can create a line between the 2 points P1 and P2. We can create a line between them without making the drawing. We are creating, and if you want to make the rendering, you can plot, or you can make the rendering, or you can draw this. You can also fill a shape. If you have a shape, for example, an oval, you can draw this oval, or we can fill this oval with a polygon. Now here we'll talk about two methods, the draw method and the fill method for a shape. So first of all, we have to understand what does it mean, shape. Okay, so Java 2D provides facilities to construct basic shapes and combine them to form more complex shapes. Now, the basic shapes that you can have a line, you can have a rectangle, you can have a round rectangle, you can have ellipse, you can have arc, you can have quadratic curve, you can have cubic curve, and you can have polygon. So these are the basic shapes. So line means you have a line, rectangle, it is a rectangle like this, round rectangle, so it is a rectangle, and you are rounding the corners. For the ellipse, you know how to make an ellipse. The arc is a part of an ellipse. So this is an example of arc. So you have a part of an ellipse. Quadratic curve here, it is so when you have a line like this, you can change this line to make it, for example, like this. Now we have a line like this. So this type of line is called quadratic curve. So 2 points, P1 and P2, and here you have another point which is called the control point. And here it's like this control point, we try to change the shape of the curve. So initially we have a curve like this, and then we will try to bend this curve to make it like this. To do this, we need to define this control point, and you'll see some examples. This is a quadratic curve. Okay, and you have the cubic curve. Cubic curve, that means you have a curve from P1 to P2, and then you have two control points. For example, one control point here, and another control point here. And then our curve will not be like this. So this control point 1 will try to change the curve to make it like this. And this control point 2 will try to change the curve to make it like this. So our final curve will be something like this. So this control point try to change the value or the plot of the curve. And this control point also try to change our curve. So this is called cubic curve. And then we have polygon, that means we have many points. So here we have an example of polygon, okay? So let's see the shapes that we have of the shape interface. So this is the shape interface. So here we have principally, we have the rectangular shape. The rectangular shape, what do you have? We have the arc 2D, or the ellipse 2D, or the rectangle 2D, or the round rectangle 2D. And how to create an arc here? You can use arc2d.double, and you have arc2d.float. So what's the difference between double and float? So with double, you have more precision. So here with float, you have 32-bit number, and with double, you have 64-bit. And so you have more precision if you have double. And same thing for the ellipse 2D, you have to use ellipse2d.double or ellipse2d.float. You will see examples, okay? For the rectangle, you can use rectangle 2d.double, rectangle 2d.float. And for the round rectangle, you can use also round rectangle 2d.double and the round rectangle 2d.float. Okay? You can have also polygon, you can have just a rectangle, area, and general path. We'll see how to create the general path, we'll see how to create polygon, and how to use the area. Now for the line, how to make the modeling of line, you can use line2d.double, you can use line2d.float. Okay, for the quadratic curve 2D, you can use quadratic curve 2d.double, quadratic curve 2d.float. And same thing for the cubic curve. Okay, so here for the quadratic curve, we have 2 points, and then you have a control point. You need to plot like this. This is the control point. P1, P2, and then we have the control point here. So you can see that the control point is outside. So generally the control point is outside the plot, outside the curve. And for the cubic, you need 2 control points. And then you have cubic curve 2d.double and cubic curve 2d.float. Any question about this? So now, by using here the shape interface, we can make the modeling, and then we can make the rendering. Okay, so here, let's suppose that you want to use line. We want to create a line. So to create a line, you need 2 points. P1 and P2. So how to create a line? We have to use line 2D, and then we have to give the name of the point or the name of the line, for example, L equals new. So here we have to create an instance of line new line 2D dot double or line 2D dot float. So to create a line, we can use line 2D dot double or line 2D dot float. And then we have to give the 2 point P1 and P2, or the coordinate of P1 and the coordinate of P2. So this is how to create a new line. So line 2D, then we have to give the name. This is the name. Okay, so here we have to create a new object. So we have to use the new to create a new object. Then you can use line 2D dot double or line 2D dot float. And then you have to give the coordinate of the first point, and then you have to give the coordinate of the second. So this is here the design part or the modeling part. So this is the line 2D, and the name is line equals new line 2D dot double. And this is our first point P1, and this is the second point P2. This is the modeling. And now I want to make the rendering, so I have to draw the line. So I have to make G2.draw, and then I can draw the line. Okay, so you can see this directly. This is our skeleton. We don't need here our new quick poison. Copy the translate. Okay, so now I want to create a new line. So we can also create a point. Okay, but let's start with creating a line. So how to create a new line? So here, for the shape interface, we have line 2D. So line 2D, and then we have to give a name, for example, L equals new. And then we have to use line 2D dot. So here you can see that you have dot double or dot float. Let's see dot double. And then here you have to give the coordinates. So if you have already 2 points, you can use here point 1, point 2. If you don't have already point, you can give here the coordinate of the first point and the coordinate of the second point. So here we didn't define any point, so you can use this one. So here, let's create a line between 100, 100. So 100, that 100. The second point, let's make it 300, 300. Okay, so I have to make semicolon. Now, if we run, so we have done, but you cannot see here, you can see anything. Why we are not seeing here anything? But because we made the modeling without making the rendering. Now, very good. So how to make the rendering now? Now I want to plot, or I want to draw the line L. Okay, so we can make G2 dot draw.
Draw L.
Draw L. Very good. G2 dot draw L. So now when we run, you can see that we have our line L. It's clear?
Doctor, why can't we use just draw line without creating an object?
Because here we are using Graphics Studio. You have more options with the Graphics Studio. Okay? When we draw line, it's okay. But if you want to, if you have any shape and you want to fill the shape by using a texture, for example, or an image, you cannot do this by using the graphics. You have to use the Graphics Studio. Okay? You have more features by using Graphics Studio. Okay?
Okay.
Now, let's see how to do it by using the point. Now, we can create 2 points. So you can see here, you can see that we can have also some points. So it's not written here, but you can create a point. So let's create some points. Now, point, let's call it P1 equals new point, and then we have to give the coordinate of this point. Yeah, let's use now 100, the first point. Okay, and let's create another point P2 with the coordinate, for example, 200, or let's make it for the x-axis 300, and just use the same y-axis 100. Okay, now I have to change. Let's make it P2. Now I want to create a line between P1 and P2. So here I can remove this. So here you can see that you have here 3 parameters or 4 parameters. Okay. Now I want to use the point. So here instead of giving 4 parameters, I can give just 2 parameters. The first parameter is P1. The second parameter is P2. So now we are changing the constructor. So here I can make a line between P1 and P2. Okay, so now we can run. You can see that you have a line between P1 and P2. Let's change the color. You can change now P1. When you change P1, you can use 400. Now you can see that you are changing the line. So here we created 2 points, and then we created a line, and here we are drawing this line. Any question about this? So, like the line here, we can create a rectangle, we can create an ellipse, we can create a round rectangle, we can create an arc, etc. So we see all these methods. So this is how to make a line. So we are making a line between the 2 points, 100 or 10, 10, and the second point, 200, 200. And then we are drawing the line. Okay, so in addition to the line, we can have, so here we are talking about just one line like this. Now, if we need a line like this, we'll see that there are 2 types of curve. Okay, so we see the quadratic curve and the cubic curve. And to do this, we need some control point. Okay, so to make a curve like this, we can have our P1 here, we can have our P2 here, and then we have a control point. So to make something like this, the control point should be, so we should have the same distance here. So this is the control point. If you make a control point here, with P1 here and P2 here, we can have a curve like this one. Okay, so we can have 2 control points if it is cubic curve. Cubic curve like this one, for example. We have 1 point here, 1 point here, we have 1 control point here and another control point here. So it is here the cubic curve. Or, okay, cubic curve. Here we have quadratic curve. So for cubic curve, we need 2 control points. For quadratic curve, we need 1. So we have an example. So to create a quadratic curve, we can use quad curve 2D to represent quadratic curve. So it is defined by 3 points. So what are the 3 points? P1, the control point, and we have P2. So the ending point are P1, P2. The control point is the third point. Okay, so the middle control point usually is not on the curve. So here you can see that the control point is not in this. So in this example, the control point is somewhere here. This is the control point. Okay, so let's see how to do this. So here we have quadratic curve, and then you have to give the name. It is a new quadratic curve dot double or dot float, and then you have to give what. So the first point here is this P1. You have to be careful here. And then the second point here is the control point. And then you have here our P2, which is the ending point, the second point. Okay? Any question about this? Yeah, now let's try to, okay, we can run this. Okay, so we designed it with the line. We are not drawing the line, we don't need it. Now let's create a quadratic curve. So we want to use quad curve, and then what to do name, let's make Q1 equals, we want to create a new instance, so new, same thing, you want to use quad curve 2D dot double or dot curves. Okay, so quad curve 2D dot float. Let's read the double. And then here we have to give how many points?
2 points and control point.
Very good. So let's make the first. Okay, let's try to design like this. Okay, so here we have the first point 100 from 100. Our second point here is 400 from 100. And just suppose that I want to create a curve like this. And the distance here is 100. So in that case, this is P1. This is our P2, and the control point will be here. This is the control point. So what is the coordinate of the control point? So for the X component, what do you have? We have 400.
200.
Okay, so here we have for the X component, here 400, here 100. So distance is 300. So we are at the middle. So here we have 150 plus the initial 100.
250.
So you have 250.
200.
For the Y component, so initially here we have 100. And here, this point here is also an additional 100. And our point is here. So what is the Y component here? So 1 plus or 100 plus 100 plus 100. It is
400.
we have already 100. Then we are adding this 100 and this 100. So it is 250, 3. So let's try to do this. So here the first point, P1. What is P1?
100. 100.
Then we have to make the control points. What is the control point? 250,
150.
And 300.
300.
300. And then the point P2, what is the coordinate of P2?
400. 100.
Very good. And then we want to draw this L. Okay. So now we want to draw what? Q1. Let's draw here Q1. We can run this. It's close. And you can see that you have this. Okay. Now, let's draw the first curve. So let's draw the curve from this point to this point. So here we can use line 2D. So we have already from P1 to P2. We can draw the line area. So we can use G2 dot draw. And then you can draw our L. Now we are drawing what? So for the modeling part, we created L and we created Q1. Okay, and then for the drawing, we are drawing Q1 and we are also drawing L. You can see that you have here L. This is L and this is Q1. So you can see that the control point is somewhere here. This is the control point. This is P1 and this is P2. So here for P1 we have 100 from 100. For P2 we have for X 400 from 100. And here for the control points, now this control point as the coordinate for the x component, we have already 100 plus 150, so 250. And for the y component, we have already 100 here, plus this 100, plus this 100. So it is 300. So this is our control points. Is this clear? Okay, now let's suppose that we want to make this plot. So let's make an application. Yes, go ahead, please.
الكنترول بوينت ليش ما حسبناها من الصفر يعني؟ ليه حسبناها من النقطة الأولى؟
So
حسبنا
if
الإحداثية حقتها.
you need a curve like this, your control point should be here. What is the coordinate of this point? Let's call it P3. What is the coordinate here? So this is our 0. This is the 0, 0 is here. So for the x component, what do we have? We have already. So we have 100, 100. So from here to here, what do we have? We have this 100 plus this 150. 150. And for the y component, we have this 100 plus this 100 plus this 100. So the coordinate here is 250, 300.
أوكي شكرا.
Okay, so we start always from this origin. Okay. In hi-fi or in sound system. So we have here this center. Okay. Now let's suppose that you have the point, for example, here let's start with 100. From 100, here what do you have? Let's make it here 200, here 300. That means you will have 100, 300. This point, let's add here 100 and here. Okay, let's add a total of 100. So here we have 200, 100. And here we have 200, 300. Yeah, can you give me the first control point? What is the coordinate of the first control point? So I want to create this curve.
150 for x.
So if you make the 150 يعني هنا. If you make the control point here, the curve will be like this. Very good. So the control point should be here. And the coordinates 200 for the x component. And what about the y?
50.
And y. What is the y here? So 200. We have already here 100 because this point is 100, 100. So here 100 plus this 100 equals 200. And the first control point here will be 200. This is the control point 1. Now to create this curve, we have to make the control point here. So what is the coordinate here for the x component? What do you have?
100.
100 for the y component.
200 also.
Very good. And let's try this. So we don't use the line and we want to make quadratic curve. Now the first point here, let's start 100, 100. Then the control point here, 100, 200. Okay, so 100. What is the second control point here? Okay, so I will write. So here we have P1. And this is P1. And here we have P2. P2 should be here, okay? And here I will call it control point 1, so the control point 1 will be, okay? So P1, 100, 100. The control point 1, what is the coordinate here? Control point 1.
200, 200.
Very good. 100 and 200. And what is the point 2?
100, 300.
100, 300. Okay, and let's create the line between P1 and P2. So how can we make a line? We can use line 2D. Let's use here the same line. Let's make now the line between P1 and P2. So what is the coordinate of P1? 100, 100. Coordinate of P2? 100,
300.
300. Okay, let's check this. Now we have to draw Q1, we have to draw L. Okay, let's run this. Now we have the first parts, okay? So you can see that here we have our point P1, here we have our point P2, and here we have the control point 1. Now we have to, let's use here P3 and P4. We can make this line, and then to make this line, the control point here should be here. Control point 2 is somewhere here. Okay, now let's do this. Now we have white curve. Let's use the Q2. And then, Yalla, give me the values here. What is the first point?
200, 100.
100.
200, 100. Then the control point.
200, 200. No, 100, yeah.
100, 200.
Very good. 100, 200. And then
200, 300.
200, 3. And the line between the first point, which is 200, 100. And then the second point is 200, 300. And then you have to draw. So here you want to select another name, for example, L2. You have Q2 and L2. You have G2 draw. You have to draw L2. And you have to draw also Q2. So this part here is the modeling part, and this part here is the rendering part. Okay, so we can run. You can see that now we have this. Here is everything. You can see that we have here the shape that we need. Is this clear? This is for a quadratic curve. We have 2 ending point and 1 control point. Okay, so let's continue. We have done with the quadratic curve. Let's see now the cubic curve. So the cubic curve here, we have, as I explained it, so let's see how to create this curve. So have the end point P1 and P2. And we have one control point here, control point 1, and here we have another control point 2. And you can see that the control point 1 and control point 2 are outside the curve. So how to do this? You have to use it. Any question?
الشيرنج طفى ما نشوف شاشتك.
Upload your browser or your Teams. I'm sharing. So it's problem with your rating system. So just wait for moment between here. Okay. Is it okay for the other students?
Yes.
Okay. Okay, so here we are creating a curve or cubic curve. So we call it also the Bezier curve. So if you use, for example, Photoshop, you can find that there is one icon, Bezier curve. Okay, so in the Bezier curve here, we have to use two control points. Okay, so how to do this? You can use cubic curve 2D. Then you can give the name, then new cubic curve 2D dot float or dot double. And then here, what do you have? You have 4 points here. So we have the two ending points. This is P1 and this is P2. This is our P1 and this is our P2. And then we have the control point 1. See, this is our control point 1. And here we have the second control point. This is control point 2, ultimately the control point 2. Is this okay? So here in this example, this is P1, this is P2. Here we have the first control point, and here we have the second control point. Okay. And this. We can try this. Now let's choose instead of what curve, now we need cubic curve. Let's do it. Okay. The curve 2D. Then we can use, for example, C as a name of C1 equals new cubic to D dot double or dot float. And then we have to give how many points? 4 points. 8 parameters, so 4 points. Okay. Now let's create something that is okay. Let's suppose that we want to make. Let's suppose that we have here P1 and then we have P2. And here let's start like usually 100. So this point here, let's make it 100 or 100. So the distance here is 300. Okay. And let's make a curve like this. Okay, so to do this, we need a control point here, and we need a control point here. Okay, so let's have this control point, for example, 100, 100. So let's make this control point 1 with the coordinates 200, 200. And let's have this control point 2 with the coordinates. Let's use the 100 minus 100, so have 0, 300. Is it okay? So here, what is the distance here? It is here 50. Here we have the distance of 50. Why 50? Because here we use it 100 for the control point. Okay, so let's try this and check the results. So we have cubic curve 2D. Okay, so here we have to give the coordinate of the first point. Yep. What is the first point? P1.
100, 100.
100, 100. Very good. Then we have to give the first control point. Control point 1.
200,
200, 200.
Then the control point 2.
0, 300.
And then the end point P2.
100, 400.
100, 400.
That's it. And then this semicolon. And then we don't need the line. And then we have to make G2 dot draw. And then the name is C1. Now we can run. You can see that we have this shape. Okay, so that is our P1. P1 is here. Our P2 is here. Our control point 2 is here. Our control point 1 is almost here. So we have almost the same shape. So here, if you have here 100, so here it will not be 50. It will be less than 50. Okay, and be probably the third because we have two control points, not one. If you have one control point, it will be exactly that. But if you have two control points, one control point will try to. So the trend of the curve will be in this direction, and here we have another trend in this direction. So here it will be almost the third. Okay, so that's why here we have the flow lines. So this is our 100 from 100. Here we have the second control point, 200 from 200. This is the second control point or control point 2, 0, 300. And here we have the end point, which is 100, 400. So you can see that here, if we trace this, you can see that here we have almost the third of this that we have on here. Okay. Is it clear the cubic curve? In the cubic curve, we have to make two control points. Okay, and the syntax is that you have to make the first point, P1, you have to make then the control point 1, you have to make the control point 2, and then finally you have to make the point P, the end point P. Any question about this? No questions. Okay, so I've done with the lines and with the curve, with the cubic curve, and with the quadratic curve. Okay, let's continue. Now we can also make, we can draw a rectangle. We can draw also round rectangle. So same thing, if you want to make a rectangle, you have to indicate a point, like you have here, P1, for example, with the coordinate X and Y. And you have to give same thing the width, and you have to give the height. And then we can create a rectangle 2D, and then we can give the name equal new rectangle 2D. So here you can create a rectangle 2D. You have two options here. Okay, so you can just use new rectangle 2D, and then you can give P1 and the width and the length, or you can use the new rectangle 2D dot double or new rectangle 2D dot flips. Okay, because in the shape interface you have here two options. You can use here the rectangle 2D by using here rectangle 2D dot double and rectangle 2D dot float, or you can use here just this rectangular shape. Okay, now let's create here by using rectangle 2D dot double. Let's create a rectangle. Yeah. Rectangle 2D is for R equals new rectangle 2D dot double. And then let's use the point. Let's start from 0, 0. And let's have a width of 300 and a height of 100. So here we made what? The modeling or the rendering? model. Now how to make the rendering? For the rendering, now we have two options. We can fill this rectangle and we can draw this rectangle. So we can make G2 dot draw what? Now we can draw art. So we can check this. Now you can see that we are drawing this rectangle. We can also fill the rectangle. Instead of G2.draw, we can use G2.fill. Now we can fill this rectangle by using the color that we have used, which is the red color. Now we are filling this rectangle. We can also use round rectangle. Let's change the color. Now let's use round rectangle. So same thing, round rectangle 2D, new round rectangle 2D, and then we have to give the two diameters, like explained previously. So we can make, for example, 30 for D1 and 30 for D2. Now we created a round rectangle. Now we can fill this rectangle. We can draw this rectangle. Now let's fill the rectangle. You can see that now we are filling this rectangle and it is a round rectangle. You can see that we have a round corner. So you can see that we have a round corner. We have also round. So we give here R1 and or D1 here and D2. Okay. Same thing, we can create an ellipse. So here we don't have, it's not an oval. So here in Java 2D, we are calling the oval ellipse. So we can create an ellipse. So this is for the rectangle. And for the round rectangle, we have done this. So this is the ellipse. We have seen the parametric equation of the ellipse, which is x equals a cosine theta and y equals a sine theta. This is for the circle. If you want an ellipse, here we have a and here we have b. So the same value, it will be a circle. If you have two different values here, it will be an ellipse. And same thing to create an ellipse. So we can use ellipse 2D. Then you give the name. We can use new ellipse 2D dot float or dot double. And then here we have to give the coordinate P1. And as usually, this is our P1. P1 is here. This is our P1. And this is the width. And this is the height. Okay. So we can create an ellipse. So here you have to be careful. X1 and Y1 are the upper left corner of the bounding rectangle. And this is our bounding rectangle. We are talking about the upper left corner. And W and L are the dimension of the rectangle. You have the W, and I prefer using H because it's not the length, it is the height. Okay? So that's why here I use H. Okay? Now let's create an ellipse, and then let's create an arc from this ellipse. Okay? Let's start with the ellipse. So here, so ellipse 2D, and then let's use E equals new ellipse 2D dot ellipse 2D and the new ellipse 2D dot this should be double. And then you have to give the upper left corner. Let's start from 50, 50, and let's have a width of 200 and a height of 100. Okay, then we have to make semicolon. Now I have to draw the ellipse. So G2 dot draw. And then I want to draw E. And then we have to make it. And run. You see that we have here this ellipse. Okay, we have the coordinates P1. This is P1 here. And here we have the width. And we have the height. Any question about this? Now we can fill this ellipse instead of the row, we can just fill. And now we are filling this ellipse. So here we have the modeling part, and then we have the rendering part. Now let's create an arc. So an arc is a part of the ellipse. Okay, so how to create an arc? So to create an arc, we have to use Arc2D. So Arc2D define an elliptic arc. So it is the portion, the portion of the arc defined in a range of the parameter theta. So we have to make Arc2D, then we have to give it a name. Equals new Arc2D.float.double. And then we have same thing. This is P1. This is the width and the length, or width and the height. And then we have two theta. So here we have the starting theta. And here we have the angle theta, what is the angle that you need. And then here we have two options or three options for the arc. When you draw an arc, you can draw an arc. Suppose this is the center. You can draw an arc like this. This is the center. We can draw an arc like this. And also, this is the center. We can draw an arc like this. Suppose this is the center. So this one here is a phi. It's called phi. So here we have open. Call it open arc, and here we call it short arc. Three types of drawing the. Okay. So let's try this. Instead of creating an ellipse, let's create an arc. So arc 2D. Let's use A equals new arc 2D dot double. And then we have to give the coordinate of the first point. Let's make it 100, 100. And have to give the width. Okay, let's make it 200. And with the height, let's make it 100. And then for the theta, let's make theta 1 equals to 0 and theta 2 equals to 90 degrees. Okay. R2D equals R2D dot double. What's the problem here?
Make it open, I guess.
Okay, so here something is missing. So here we have to give what type of arc. Okay, so here we have to give arc 2D dot, and then we have here the options. Now, what are the options that we have? So we can have short, you can have open, and you can have phi. Let's start with phi. Okay, and then we have to fill the A. So raise everything, and let's now, what do we have? We have this arc. Okay, so our P is, so this is the complete ellipse. Our P1 is here. Then we have 200 and 100. This is the 200. And this is our 100. And then we have 0. So we start from theta 1. Theta 1 is at 0 degree. And then we have theta 2 is 90 degrees. So from theta 1 to theta 2, so we will have an arc of 90 degrees. This is theta 2. And then we have a pi, that means we are drawing like here, like a pie, like a pizza. So we are drawing this line with the arc. We can here change this pi, we can make it as open. And by this, you can see that now we have open arc. We can try the short. And this is the short. So here it is giving the short and the open. We are making feet, so let's draw here. Okay, let's draw now arc. So this is the short arc, and this is the open arc. Is it clear, the difference between short, open, and pi? Let's make the pi. This is the pi. So we can start, for example, from 45 degree to 45 degree like this. And see the difference. So here you can see that we have an oval. Let's use 200, 200. We will explain theta 1 and theta 2 again. So here the theta 1 is from here to here. This is theta 1. And the theta 2 is from here to here. This is theta 2. Is it okay? So theta 1 here is 45 degree. Theta 2 here is also 45 degree. So have this arc. And since we are making pi, so you will see these two lines in the arc. Any question? So you have any? على حسب الرسم. It depends what you want to make, okay? So here we have three options. So here what do you have? You have pi, you have short, you have open, you have the complete ellipse. Okay, so here you have the open, here you have the pi, and here you have the short. So if you are filling instead of drawing, you are filling, so you can see that the open and the short, they will have the same output, because if it is open and you want to fill, this will fill this area, like the shorts, okay? Now, let's see how to make polygon shape. So what does it mean, polygon? So here we have many points, okay? So I have many points. Let's suppose that you want to do this polygon. Let's suppose that here we have P1, then we have P2, P3, P4, P5, P6, and P7. So here we have a polygon with how many lines? Here we have 7. With how many points? We have 7 points. Now to create a polygon, so we can use here a polygon. So polygon followed by the name equals a new polygon. And here we have to give here the x poly. So x here is a vector or an array containing the x of all the points. And y is another vector containing the y of all the points. And then here we can give the length of the polygon. For example, let's suppose that I want to make a polygon with 3 points, P1, P2, and P3. Let's suppose that P1 is 100, 100. Let's suppose that P2 is 200, 100. And let's suppose that P3 here is for the X component 200, and for the Y component it is 200. And I want to draw this polygon like this, which is a triangle. This is picture, okay? Now, so the vector X here, or X poly. So here it is a vector containing the X of all the points. So how many points do we have? 3 points. So what is this vector X here? So our vector here, X, will be a vector with the values. So the first X is 100. The second X is 200. And the third X is also 200. Okay? And this is for the X point, okay? And what about the Y? Same thing, it is a vector or an array containing what? The Y of the 3 points. So the Y of the first point is 100. The Y of the second point is also 100. And the Y of the second point is 200. So first of all, you have to create the vector X, then you have to create the vector Y. Once you have X and Y, you can create the polygon. And after creating the polygon, you can draw the polygon or you can fill the polygon. Okay, so let's see what we have here. Okay, so I have here the vector. So here what do we have? We have an array of integer named X poly. So I can make it X. Okay, and you have an array of integer named Y. And here we have the coordinate of X, we have the coordinate of Y. Now, can you give me the coordinate of the first point? Very good. So here you have the first point. The first point has the coordinate 150, 150. So P1 here will be point with 150, comma 100. P2 will be this one. This is P2. So P2 will be another point to be probably here. This is P2, 150, comma 100. Etc. Okay. Now we created vector X, which is the vector having the X of all the points. Then we created the vector Y, and now we can create the polygon. So polygon poly equals a new polygon, and then we have to give the vector X, the vector Y, and the length. So here for the length we can make 7 because we have here 1, 2, 3, 4, 5, 6, 7 points. Or we can use the method length of the vector X or vector Y. You can note X dot length or Y dot length. Okay, then we can select the color that you need, for example, red, and then you can draw the polygon. So you can see that now we have this polygon. And where is our P1? This is our P1. 150, 150. This is P1. This is our P1. Then we have P2, etc. Okay, this is P2. This is P3. Because the P1 has the coordinate 150, 150. And then here we are making the line, or we are connecting all the points of the polygon. This is P7. So here we use draw. We can also use fill. You can see that now we are filling the polygon. Now, for the length, we have here 7. Okay, so the length is 7. But what happens if we change the length? So if the length is 7, we can make 7. But if we make the length 6, for example, so you can see that we removed the point P7. So P7 was somewhere here, and we remove this point. So you just 6 points. If we make here comma 5, so we remove this point P6. So the polygon will be like this. Okay. Is it clear? This is very good. Okay, now we have seen how to create some shapes. Now we'll see how to combine the shapes together. Okay, so we can combine several existing shapes, and it is known, so this operation, it is called constructed area geometry. So what can we do for the area? We can have the union of two areas. We can have the intersection of two areas. So here we have the two areas. This is the first area, and this is the second area. And in this example, we need just the intersection. Here we need the union. In the third example of the subtraction, we have one area, and from this area, I want to subtract this area. We can have also the exclusive or, yani everything except the intersection, or the union except the intersection. So we have is the union without the intersection. It's called the XOR. Okay, so here we can have this operation. We can use both intersect, we can use add, we can use subtract, and we can use exclusive or. Okay, so we have the example. We are creating the two shapes, S1 and S2. These are the two shapes. Okay, and so here what is the shape S1? So you can use here, you can use ellipse 2D S1, or you can use just shape, because the ellipse is a shape, the rectangle is a shape, the arc is a shape. Okay, so here we are using just shape instead of ellipse 2D. Okay, so here shape S1, we can use new ellipse 2D dot double, so this is the first ellipse, and then here shape S2 will be S2 here, which is the new ellipse 2D dot double, and then we have here the second shape. So here the first one at the position 0, 0, the second one at the position 60, 0. And from the shape, we are creating the area, because if you want to make intersection or union, you have to do it for area. So you have to create area. Okay, so here we are creating an area unit, area A1. Okay, and then you are creating the area S2. So here area S2 equals new area. So area A2 equals new area of S2. So the area A2 here will be the area of the shape S2. Okay. Then we are making a translation of the points so that we can see the right. And then what do we have? We have G2 dot draw S1, G2 dot draw S2. So this will draw these points. Okay. Then we are translating the graph 200 over the y-axis. Now the new origin is here. And now we are making combination. Now in this part, we want to add the two shapes together. So how to add the two shapes? Now I have to create A1, which is a new area of S1. And then you have to make A1 add A2. We are adding here A1 to the shape A2. Okay, so what are we doing here? We are adding A2 to the area A1. And then we are filling A1. So this will be as the addition. Now we are translating over the x-axis by 180. So the new origin now is here. And we are creating again A1 a new area of S1. And then what are we doing? We are making A1 dot subtract A2. So what are we doing here? We are subtracting A2 from A1. And then we are filling A1. So this will be as this shape. Okay, something is missing here. So the subtract will be as this part. Okay, and then we are making translate. We are same thing, creating A1 again, and then we are making exclusive OR between A1 and A2. So it will be as this is 4. For this one here, it is an intercept. So we don't have an example of intercept, so we can try this. Okay, start. So we shapes we want to make S2, area A1. So we make this S2 capital letter. Translate G2 dot draw S1 and G2 dot draw S2 are making translation, and then the area A1, new area of S1. Okay, A1 dot add A2, then we are filling A1. So this will be as the first part. So we can try to execute this. So here, what do we have? So first of all, we are drawing S1 and S2. Drawing S1 and S2 will be as this part. This is the drawing of S1 and S2. G2 will draw S1, G2 will draw S2. And then we are translating the origin over the y-axis. So the origin was here, now it is here, almost here. Then we are creating the area A1 from S1, and we have already the area A2 from S2. And then we are adding A2 to add1. So when you add A2 to A1, this will be use this shape. And we are now filling the shape. Any question about this? Now we can translate this point to this position by here making translate over the x-axis of 180. Now our new orbit is here, so the plot will be in this area. Now G2 dot translate 180,0, then A1 equals the new area of S1, capital letter, A1 dot subtract A2. Now we are subtracting A2 from A1. And then we are filling A1. This will give us the second plot of the subtraction. And here same thing. S1. And then I will give exclusive OR of A1 and then G2 dot fill A1. We can run this. So we can see that here we have the original values. Here we have the union. Here we have the subtraction. Here we have the exclusive OR. So what is missing here? Is missing here is the intersection. So how can we make the intersection? So we can translate again. We can translate over the x-axis 180. So A1 equals new area of S1. And now instead of making exclusive OR, we want to make here the intersection. So for the intersection of use here, intersect Okay. Now to use the method intersect. A1 intersect A2. And now you can see that we have the intersection. This is the intersection. This is the exclusive OR. This is A1 subtract A2, or we are subtracting A2 from A1, and here we have the union. Any question about this? Okay, so it's okay for today's class. We will continue, inshallah, in the next class. Okay, so in the next class, we see the general part. So general part is another way to create a polygon. Okay, and here we'll see the functions or the method move to, line to, quad to, cubic to, and how to close the path. And we'll make some examples how to create symbols like this one, or how to create a path like this one. Any question before leaving?